Okay, here's our second example of using all of our knowledge of unfamiliar functions and our calculator skills to answer an application problem. This is same page, number 3. A closed box is to be constructed with length 3 times its width. The volume of the box must be 6 meters cubed. And then they give you this picture of the box, and they've identified that the base is 3x, the width is x, and the height is h. So part A, if the box is x meters wide and x meters high, show that h equals 2 over x squared. So in that case, it's probably baffling as to how you're supposed to do that, except remember that they also gave you this key information about the volume, and the volume is actually 6 meters cubed. So if you remember anything about a prism or a cube or whatever, a 3D box, when you find the volume of a 3D box, it is length times width times height. So we have volume is going to equal length times width times height. And in this case, we know that 6 is equal to the length, which is 3x, times the width, which is x, times the height, which is height. And if we simplified that, we would have 6 equals 3x squared times h. Divide by 3x squared on both sides. And you're left with 2 over x squared equals h. So there we just showed it with all of this work, that the height is equal to 2 over x squared. Part B, hence, show that the surface area of the box is given by a of x equals 6x squared plus 16 over x meters squared. So now we need to think about surface area. Surface area is the sum of all of the areas of the surfaces of the box. Or if you think about it in terms of what you would paint, if you were painting the box, all the surfaces that you would paint. So we know that there are 2 of each type. So there's this front here that is, 3x by h. Then there's the side here, which is x by h. And then there's the top there, which is 3x by x. And there's 2 of each of those sides. So we know that we're going to have 2 times 3xh plus 2 times xh plus 2 times 3x squared. But remember in part A, they told us that h in terms of x was 2 over x squared. So everywhere we've got an h, we can actually substitute the 2 over x squared. So this becomes 6x times 2 over x squared plus 2x times 2 over x squared, and this is a 6x squared. So if we combine here, we get 12x over x squared, which is just 12 over x. Here we get 4x over x squared, which is just 4 over x, and all, not equal, sorry, plus 6x squared, and combine all that, you get 16x plus 6x squared. So there we just showed that the surface area, by doing all this math, we showed what the surface area was what they said it was. Remember that on a test question or an exam question, if you can't show that, you would lose points for that question, but that doesn't mean that you can't do the rest of the question. All right, now we get to part C. Find the vertical asymptote of y equals a of x. So this here is the equation of a of x. And in order to find a vertical asymptotes occur when there is a denominator and a variable in the denominator. So we would take that denominator, set it equal to 0, and that would tell us the equation of our vertical asymptote. So we know that our vertical asymptote is going to occur when x equals 0 because there's nothing else in the denominator but 0. All right, then it tells us to draw it. So before we draw it, let's you could go to graph paper and make a table of values and sketch this out, but we have calculators, so we're going to go to our calculator and we're going to type in the equation 6x squared plus 16 divided by x. I don't need any parentheses or anything because x is by itself in the denominator and the 16 is by itself in the numerator. It's not 6x squared plus 16 all divided by x. It's 6x squared plus 16 divided by x. Don't know what it looks like, so I want to start with the standard window, so I zoom 6 to graph it to begin with. Okay, that's probably not helpful, right? Anything that's happening on the left side of our y-axis, those are negative values. I'm not going to have a negative x value here, so that doesn't really make a lot of sense. So in order to graph it, I need to change my window, and I need to think sort of about what I think a reasonable surface area might be. This thing is measured in meters, and we know that the volume is 6 meters cubed. So, you know, I'm not sure what our surface area is going to be, but let's just make our window. I know I can't have any negative x values, so that's going to be 0. And 10 wasn't big enough, so let's go for 100. It's probably too big, but you don't know. I'm going to change the x scale to 10 also. I can't have any negative values for y because the surface area will never be negative. And I mean, if x is, 5, say, I don't know, we're looking at, again, maybe around 100 if we just sort of estimate things. So again, just sort of eyeballing it. If I go back to this, if x was 5, then this would be 15 times like 2. Well, 15 times a half, and then this would be another 2.5, and this would be another 15, 5. I don't know, 100 is probably too big, but we'll figure it out. And graph it and see what we got. Right, okay, so here is our information. 100 was definitely too big this way. So remember, this was 100. We counted by tens. This was 10. This is 20. So maybe let's change our graph so that our window, our x max, only goes up to 20. That should help us find things a little more easily. There we go. That's easier to look at. Good? Okay. So we're supposed to use the graph to predict the surface area with a box of width of 2 meters. So here's what they were saying about how to sort of estimate it. If you think the width is 2, you can kind of just put in 2 there and you get about 6. Put in 2 there, you get another, you get an estimate. All right, so now we're using technology to check our answer. So that means we're trying to figure out what the value is when x equals 2. So the easiest way to do that is probably to look at the table. So second table, and when the width is 2, the surface area is 32. Right there. So great. Okay, then it says find the coordinates of the turning point and explain what they mean. So our turning point is down here. It's a minimum. So let's go ahead and calculate the minimum. So we do second trace and second trace. There we go, second trace, and we want the minimum, which is 3. So we gotta put our cursor to the left. I don't even know where my cursor is right now. It should be coming down from the top any minute now. There it is. So I could tell it was coming down because I was looking at this X value decrease. All right, so left bound, right bound. Don't know why it did that, so I'm starting over. I want the minimum. All right, minimum. So it tells us that the coordinates are 1.10 and 21.8. So what do those things mean? So what that means is if we go back to our picture, so if this value is 1.1, then that means that our surface area is going to be 21.8. And given our graph, it means that that's going to be the minimum surface area of the box. So you can have a box that has a volume of 6, and you can have it, so like if we went to the left here, those would be widths that are much narrower. So that means our box is probably going to get a little taller. Because if this is X and this is 3X, you know, as this gets smaller, this is going to get taller, get longer. So this box becomes a little bit flatter. But anyways, it becomes a like flat, skinny box instead of like a normal sized tissue box or whatever. And as we move positive past that, that means that our X values are getting bigger, but our surface area is increasing because we're changing some of the values. So this point tells us at the value of X equals 1.1, so when the width of the box is 1.1 meters wide, the surface area is minimized to 21.8 meters squared. All right, that's it.